Okay, last question, guys, and again, this question, it's not that actually it's that hard. It's sort of bamboozling you with language, but it's a pretty straightforward question. Again, 'cause you're just going to chuck everything into your calculator. The first one you can use, certainly can use a calculator to do it. You probably don't need to. So we've got a function that is voltage, which is 3 sine of 100 pi t. Write down the maximum minimum values of V. Well, you'll see from the graph if you sketch it, but you probably should already know that it's a transformation of a sine curve. So the maximum value of V is going to be, so you're going to have a max V is equal to 3 and a min V equal to -3. The question isn't asking you what T gives you this max and this minimum. It's simply asking you what is the max V and what is the min V. Okay, 11B was actually answered quite well by everybody. I think Mazin, you lost a point for getting something basic. But we've asked for the transformation of V onto I, not I onto V. So that we're going to be clear about that. So how do we have to change V to get onto I? Well, first things first, you're going to multiply it by 2/3. So that means we're going to have a stretch, and it's going to be a vertical stretch because it's a male. Okay, so it's we can say a horizontal, sorry, just said it's vertical. It's a vertical stretch, scale factor 2/3, because we basically got to change that 3 into a 2, okay? And then we've also got this bit here. Now this is a female, and it will be a translation. It will be a translation, and it will be which way? Up or down, left to right? Well, it's a female, so it's going to be left to right, because women say no. And it's going to be opposite of what you think. So the vector is going to be -0.0030. I would have accepted something like moves to the left 0.003. Okay. So please try and remember that. These female ones, they go the opposite direction of what you think. Okay, so B was okay. Now the power P in this circuit is given by P of t, which is the product of your two functions. Sketch the graph showing clearly the coordinates of the first maximum and the first minimum points. So, you use your GDC. I'm just going to use Desmos to have a look. So just bear with me while I put it into Desmos. Sorry, just skip past this while I download it. And you can maybe skip past while I'm writing it in. Okay, so we can say P of, I'll put P of X, change everything to X, okay, is equal to 3 sine brackets 100, was it 100 pi? And then what was it? So let's just question again. 100 pi t, so I'm going to say 100 pi x. 100 pi x, okay, multiplied by, just stick it all into your calculator, I of t, which is 2 sine, okay, so let me just copy it, 2 sine of brackets 100 pi brackets x plus 0.003. Okay, why is it coming out strange? Well, possibly, do I have it in radians? I do have it in radians, so the reason why it's coming out strange is because I need to change my view. Let's just have a look at what the domain is quickly. The domain is only from 0 to 0.2, so that's why it's looking at. So let's change my domain from, let's say, minus 0.01 through to 0.02. And we're getting something like that. So, that's what it is. And you can find out all of the relevant points. That's where you're going to get your first maximum and your first minimum, which is what it required you to do. Okay, what it required you to sketch. And I think most of you did a good job of sketching that. Okay. Now, sketch. So we've got to sketch that graph showing clearly according to the first max and first minimum. So that's done. Find the total time in the interval from t is 0 to 0.02 for which the power is greater than or equal to 3. So that, again, should be nice and easy to see. Put in there as well, y is equal to 3. So we can see that we are above 3 between these two times here, 0.001676 and 0.005324. Let me just write those down. So we're above 0.00534, was it? Let's just check it. 5324. 324. And then also the other point was 0.001676. 0.001676. So we're above 3 for that amount of time. So I'll work that out in a second. And we appear to be within that domain is also between here and here. So 0.0153, I'll just do it to three significant figures. So 0.0153 minus 0.0117. Okay, and all I've got to do is work out what they are. So I'm just going to use my calculator. So 0.005324 minus 0.001676 equals 0.003648, and then 0.0153 minus 0.0117 equals 0.0036. So those two amounts of times I'm above, so let's just add them together. Plus 0.003648 equals, and the total amount of time 0.00725 seconds, I suppose. Is it all measured? It's all measured in seconds. 2, 3 significant figures. Okay, so again, we're just using the graph to work that out. Now, I couldn't quite believe this next one, that you didn't get it right, because it's so easy. You just stuff it into your calculator. Okay, the average power, you're told what function you've got to use. Average power is equal to 1 over t times the integral between t and 0 of p of t with respect to t. So if we want to know what the average power is when time is equal to 0.007, then it's just going to be 1 over 0.007. I think I saw one of you copy it wrong. You put 0.07. It's a crazy way to make a mistake. Integral of 0.0070 of your function, your power function, which is 3 sine of 100 pi t times 2 sine of 100 pi t minus 0.003 with respect to, sorry, it's plus, wasn't it? Okay, so you just stuff it in your calculator. Okay, just stick all of that into your calculator, and I'm not going to waste time doing that, so I'm just going to look at the answer scheme. If you puff all that into your calculator, it will just say 2.8723 significant figures. That's a question you should never get wrong, because you can just use your calculator to do that. Okay? Now, in 11F, with reference to your graph, explain why the average power is always greater than 0. Okay? Now, let's actually have a look at our graph. The reason why we can see that the average power is always going to be to 0 is because you're basically looking for because it's the integral, you're looking for the area under the graph. Well, you can see that if I go to this point here, if we go up to the time is equal to 0.007, well, the power is the area under that graph between 0 and 0.00. It's quite a large positive number. Then, when I get to 0.01, okay, I get some negatives, it's going to be taken away, but it's not going to be enough to make it an overall negative answer. So we can basically say that the sort of the central line is above 0. So the overall area is always going to be positive. Although you're going to get little bits taken away from that overall positive value, it's always going to be positive. Okay? If you're not sure my explanation with that, then just ask. Okay? The Mark scheme said this: in each cycle, the area under the t-axis is smaller than the area above the t-axis. Okay? The curve begins with the positive part of the cycle. So you can never have a negative power, because you're starting here, and the area underneath is always going to be positive up to here. Then you're going to get negative bits, but not negative enough to make the big positive become an overall negative. Okay? So again, hope that's clear. Now, this next question, it's tricky enough, but I think you should be able to do this. We've basically got to change this graph, this graph here that we've got, to be able to write out what the equation of that is. Okay? And we've got to write y equals a sine b of t minus c plus d. Now, a is easy to know. Okay? A, remember, refers to the amplitude of the function. So all you're going to do is you're going to take your maximum p minus your minimum p and divide by 2. Add them. So you're basically trying to look at the distance between the maximum and the minimum. Okay, and then the amplitude is going to be half of that. Okay, so we're going to do what's my maximum value here? 0.003. Sorry, it's 4.763. So 4.763. And then we've got my minimum is minus 1.237. So we're going to do minus 1.237. Distance between those two y values, and half it. Okay, we're going to use a calculator. So we're going to get 4.763 plus 1.237 divided by 2, and that is going to be equal to 3. So the amplitude is 3. Okay? D is also easy to know, because D is simply how much has grown up from the 0y, I suppose, is the way you could look at it. So what we want to do is we want to find what is in the middle of those two y values. So let's add them together. 4.763 add negative 1.237. Okay, so and then divide that by 2. We'll find the middle of those two values. 4.763 minus 1.237 and then divide that by 2, we're going to get 1.763. So that is how much the graph must have shifted upwards from a normal sine curve. So D is easy to find. Now, B is also easy to find by thinking about the transformations. Now, the normal period of a sine curve is 2 pi. And so what we need is some kind of scale factor to get it back to what we need it to be. Okay? Now, what we need to do is look at the period of the function. You can see that it's recycling itself every 0.01 seconds. Okay, the period means how often it recycles itself. So you can see that it starts here, it gets back to the beginning here, 0.01. Okay, so the period is 0.01. If you want to find the period of the transformed curve, or the value of B, to make it the right period, you're just going to do 2 pi divided by the period. Okay? So, and if you don't understand, just remember. Okay? So that is going to be 200 pi. So basically the value of B is always going to be 2 pi divided by the period of your function. Okay? So that finds B. Now C is a nightmare. Okay? And it really always, it baffles me. Okay? I can never get my head round how to find C in terms of thinking about the transformations. Okay? So here is a solution, a way round that problem. You leave it to last for first thing to think about. Do not do C until it's the last thing that you do. Okay? Now we know A, D and B, so I can now write my equation as y is equal to 3 sine of 200 pi times t minus c plus 1.763. Sorry, I ran out of room there. Okay. Now all I'm going to do, just to make life easy for myself, is I'm just going to pick a point that is on the curve and pick the easiest point that you can possibly know. Well, that is 0, 0. Okay, 0, 0 is on this curve. So that means if y equals 0. So let's plug that in. 0 is equal to 3 sine of 200 pi times negative c plus 1.763. Okay, so we've got an equation here. We've got minus 1.763 is equal to 3 sine of negative 200 pi c. So sine of negative 200 pi c is equal to 3 over minus 1.763. Sorry, I've done that the wrong way around. Very foolish. Okay, make sure you don't make silly mistakes like that. It's minus 1.763 over 3. Use a calculator. So we've got minus 1.763 divided by 3 equals minus 0.587, blah, 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 blah. So we're going to do inverse sine of that. And I get minus 200 pi c is equal to, sorry, I need to actually set my calculator to radians, so just bear with me a second. 4. Okay, so we're going to do it again. Minus 1.763 divided by 3. Shift sign of the answer is equal to minus 0.628. Okay, so we got minus 0.628. And so C is equal to, let's just go over here where I've got space. C is equal to minus 0.628 divided by 200 pi. So divide that by 200 pi. And I'm going to get there 0.00123 significant figures. And that is the right answer. There it is. So, sorry, that should be over negative 200 pi, so it's positive. Okay, so there is my result. So I know my final answer. It's just right here where I got space. Y equals 3 sine of 200 pi t minus 0.01 plus 1.76 if everything is to 3 significant figures or whatever it needs to be. Okay, it won't matter as long as you're clear about how you've rounded. Okay, so a little cheat there. When you get a question like this, you've got to find A, B, C and D. Find A first, A is easy to find. Find D second, D is easy to find. Find B third, okay? And remember B is 2 pi divided by the period, okay? And then find C last by just knowing one point that exists on the curve. Because trying to do it in our heads through the transformations is just a nightmare, okay? We're almost bound to get it wrong. Okay, any questions about that, let me know.